Hey everybody, just as folks are coming in, hello. I'm Mark Brown. I'm based in Raleigh, North Carolina. So it's always a joy to come and get to visit London. I really enjoy it. I'm a solutions architect specialist at MongoDB, and I specialize in edge and mobile devices and computing like that. So thank you so much for taking your time to come out and visit and hear me talk about syncing your mobile Kotlin app with your backend data today. Let me tell you a little bit about what motivates me to talk about this topic. And as we all know, it is customary to start off technical discussions at a development conference with late 19th century Gustave Doré prints depicting the rhyme of the Ancient Mariner. But it works for me because, like that Ancient Mariner, I want you to learn from my mistakes. Now, before MongoDB, I worked at a medical software company, and I wrote and maintained a great deal of the code that actually did all of the syncing between the front-end mobile applications and the back-end database, including, the network socket communication, connection and error handling, and the data sync based on the user's device ID, and calculation of changes, conflict resolution, and then upgrading existing systems that were in the field. And making sure that the database changes moved over. It was slow, it was complicated, it was buggy, it ate development sprints and QA cycles, and it was the root cause of many of our support calls. So customers, it turned out, were really good at finding the edge cases that we didn't account for. Don't do this, right? So maybe I can tell you about how we get started coming down this path. Maybe you think, oh, I'm a developer. How tough can it be? How do you start with architecting this? Well, you start and you say, I've just got some data that's on my mobile device. I've got some data on the back end. It's like writing a web application. It's like writing RESTful API calls to go get the data that you need and you bring it down. It's really easy, right? Well, it's not. It ends up being really complicated. Here's a very common architecture. That's what it might look like to do this sort of setup. Starting on the top left, you've maybe got your mobile device, and maybe it's got a relational database underneath it, like a SQLite. All right, so I've got to get data out of that. So maybe I'm going to do an ORM call and get into a Kotlin object that's on my mobile device, and then I've got to turn it into JSON in order to do the RESTful call that gets to the back end. Then I've got to figure out some way to set up push notifications so that I can get changes on the back end and recognize those on the front end. Or, oh my God, I've got to set up some polling mechanism on my front end to go and look for changes coming from the back end. So, good working sync is just table stakes though. All of the work that you're putting into this is not going to win you any differentiation. Nobody's going to go, oh boy, it syncs. That's table stakes. And that's not the worst of it. The real complexity comes from accounting for and writing code to handle your edge cases. So many things can go wrong when you're dealing with your mobile edge devices. You go out of network connectivity. You go out of network connectivity in the middle of a transaction. Do you recover from it gracefully? Well, let's hope so. The way you design your app also needs to account for how much battery life am I using off of my mobile device? How much network am I consuming by running this application? Are these requests slurping up all the power and battery life that I have on my device? And then you get to scale it. Now all of this has to work at scale, thousands, millions of devices. Now it has to work and handle all of these cases. And when you get all of that working, now you have to maintain this code base. So your team is responsible whenever this fails, with the problems only multiplying more as the usage increases. And then you have to worry about upgrading these applications. You have to change your database schema on the back end, and now you've got to maintain your upgraded application in the field as well as everybody who hasn't upgraded in the field, and now you've got both versions of your schema both hitting the same back end. This is complicated. So let's say you've got this assignment. You've got this assignment that says, oh, here's your stuff on the back end, go write the mobile application for it. It'll be easy, right? And you don't want to go down the path that we just outlined. So how do you solve this? Well, I'm here to tell you today the way to solve it is with MongoDB Atlas Device Sync. So with Atlas Device Sync, it comes in basically three sections, right? You've got your Atlas device SDKs. So this is a lightweight, ACID-compliant object data store that's on the edge device. It's powered by Realm, which you may have heard of, but the app is always connected to a network or not connected to a network, but the data store is always there on the mobile device. Number two, you've got Atlas Device Sync. That's a service provided by MongoDB Atlas. It does the sync between your edge devices and the cloud. It keeps the data updated across all of your users, all of the devices, and the back end. And then finally on the back end in the lower left, you've got MongoDB Atlas itself. This is our fully managed cloud database and developer data platform. So that's on the back end, so you don't have to worry about scaling your application as your usage increases. And because Atlas Device Sync was built to work cross-platform, you've got one data layer that can be consistent and reused across all of your devices, your phones, your tablets, your watches, your IoT devices, your point-of-sale systems, and it ensures that your data is consolidated in a single platform and all your teams have visibility into this valuable data collected off of all of these devices. So what I'm going to do today is actually show you how to stand up an Atlas App Services mobile application using your Kotlin and using bidirectional data sync right out of the box. So first, if you haven't done it already, go to mongodb.com and create a MongoDB account, all right? You just find any button that says free on it, you mash that, and by the way, you may want to do this even if your organization already has an Atlas account and you're already consuming this because it's free. You can set up your own personal account and go do your own testing on it, right? So enter the sign up information, fill it out, click create. You don't need a credit card, but you do need a valid email address in order to verify that you're an actual person and not some bot, okay? So once your email gets verified, your registration's successful, you get a welcome and you get some setup things to set up. It doesn't really matter. It gives you some initial prompts on your welcoming screen. And you can change all of those later. But then when you're setting up your first deployment, this is key. I suggest pick the M0, right? It's free. It provides you a full set of functionality. Now, it's a shared resource, so you won't see good responsiveness for large data sets. But it's perfect for doing development work, right? You select your provider. MongoDB runs on Atlas, AWS, or Google Cloud, or Azure, or any combination of these cloud providers. You select the region nearest you, you hit create, and you go along. Next, you want to set up your database user. So by default, Atlas actually generates a username based on your email address, and it generates a secure password for you, and you can just copy those off and save them safely. Now, this is different. This database user is different from the Atlas user you just created because this is specifically for the database that you're going to spin up. Atlas login gives you access to all of your databases across all of Atlas. You want to have a specific user just for your own setup. All right. You scroll down and you make sure you have access to your database in your IP access list. So by default, Atlas gives you access to whatever IP address it is that you're using to create this and sets that up for you as okay, you can only have access from this IP address. And then if you go someplace else and go to get into Atlas and use this database, remember to give yourself access to it through this setup, right? When you're ready, you hit finish, close, and voila. Now you've got your very own Atlas project with a managed MongoDB database spun up for free. And there's a lot of things that you can do from this point because you've got this database and you've got the full platform behind it. Today, we are interested in focusing on building mobile sync. So what you do is you mash that app services button right at the top. And because you don't have any app services spun up yet, you get this helpful dialog. Go hit the real-time sync button and go hit next at the bottom of it. Now there's 4 items to set up here. The defaults are fine. It lets you set up your template name and where your resources are and all that. Read it over if you want. Chances are you'll just hit create app service at the bottom. And now your Atlas app service gets created and deployed. So you can think of your Atlas app service as your back-end configuration. The app service defines all of the ways that your MongoDB data gets exposed to the world, right? All of the authentication, all of the authorization, the endpoints, the schema definitions, the access rules, the serverless functions, the trigger, all of that. All of that gets defined through this app service that you're building, okay? So to get you started, the real-time sync template that you select here populates all of that for you and just says, here you go, here's good defaults on your backend app service. And now, to get you started, that's your backend configuration. So now, go hit Kotlin, and then you can download your front-end configuration. So your front-end Kotlin app is now what's going to go connect to this app service that you've just spun up, okay? You're going to download that front-end Kotlin code, you're going to put it someplace, and you're going to fire up Android Studio. Do the build, it builds, and you get this cute little sample application over here, all right? When you actually start this application, you shouldn't have to do anything else in the code itself to get this started. Once you actually start it, enter a username and a password. It says email. You don't have to enter an email. It could just be any string. If this is the first time you've used that name and password, click the little Create Account button down here. When you click that, the Login button changes to a Create Account button, and you'll be able to log in. Now, by default, the Atlas App Service that you configured on the back end is configured to let you just create a new user automatically. Obviously, that's not something you do in production. For the sake of doing this, it just gets you there a little more easily. And that gets you to the main screen of the app. Great. So this template app, this is a very simple task tracker application, right? It lets you create tickets, mark them as complete, and delete them. It's very simple. But the cool thing is, it allows you to look at the code underneath and see how all of the sync is working, okay? So let's try it out. Go push the purple plus button in the circle, you enter the task name, you click create. And voila, there you go, that task gets added to the main screen. Well, let's check for that task on the back end. And notice you didn't do anything to say sync. You didn't do anything to say, okay, let's push this to the back end. It's already there. So let's go look for it on the back end. Go back to your browser. This is the app service that you've deployed. And then what you want to do is click on Data Services, which is that little box up at the top. And then go hit Browse Collections. So you'll go browse your collections of data that's actually available for you on Atlas. And there you will find that newly created task document. It's sitting there in your newly created to-do database that holds your newly created item collection. And all of those things got created for you automatically just when you added that task on your mobile device. And that's because your template app service was created in development mode, right? And that means that the changes that you make to your mobile app's data are automatically reflected in the back end whenever you do a sync operation. And that's part of why we call this the easy way to do sync data. You can make a change in one place and see that automatically reflected on your back end. Okay, so what just happened here? You instantiated the task when you actually fired up your application. You instantiated that task object. You persisted that realm, that item object on the realm in the object data store locally on your device. And since that mobile app currently has a network connection, the SDK automatically synced that object to your Atlas project on the back end. And if it didn't have a network connection at the time, no problem. The task is still written. It's still persisted and saved locally, and it still gets synced automatically whenever the network connection's available. And we'll demo that in a few slides here. So let's play around in the back end and the front end and watch that bidirectional sync happen, right? So this is a loop that actually starts. We'll fire this up. We'll add the item, we'll add task 2 on the mobile app, and then on the back end we click apply to refresh. There it is. And then we'll update task 2 on the back end. And there it goes. We'll mark that as complete on the front end, hit apply. The true says that it's now complete on the back end, and we'll do another more update on the back end and see that immediately show up on the front end, and then it vanishes because the loop cycles back around again. So the cool thing you'll notice about the mobile app is that it refreshes immediately. The user doesn't have to tap a sync button. The user doesn't need to pull down to refresh. You make that change in the back end, and it immediately shows up in the front end. Now, this is running, just for your information, I recorded this at about 1.5 times real life, so you don't have to see my mouse drag slowly across the screen. But really, as soon as you hit the update on the back end, boom, there it comes on the front end. That's pretty timely real-time sync. Okay? So as I was saying, this mobile app works even if there's no network connection and the app is offline. So what I'll do here is just take this mobile app offline, but leave the workstation and the back end connected so that you can see the updates that we make on the back end while the mobile app is offline. So we'll take this offline, hit that little button right there, And then we'll go ahead and add a task, right? So we're going to add task 3 on the mobile. And then we'll go update task 2 on the back end. So that gets updated. And then we'll come back and we'll bring this, yeah, that's updated. And then we'll come back and bring this back online. And immediately that updates right away. And then we'll do, on the back end, we hit apply, and you'll see the offline task 3 appears right away. So it really doesn't matter to the mobile user if they're online or offline. It just works. The app can still create tasks, it can still mark them as complete, it can still do all of this stuff. It's still syncing bidirectionally as soon as the thing comes back online. And now here's the really cool thing. All of this behavior that you're seeing, all of the online, offline handling, the automatic data updates, the bidirectional sync, the update of data from multiple sources, back end and front end, you don't write any of that code. All you have to worry about is getting the local behavior on your mobile app to work correctly, right? And you can leave all of that device sync to the Atlas SDK. All right, so let's see what that actually looks like in code. So in your Kotlin app, let's go and open up this template app that we've got. And you've declared a class with the same member variables as the document that you're syncing in the back end. So the white box is the document that you're syncing in the back end. It's got an object ID, it's got a Boolean and a couple of strings, right? Very simple. So in order to mimic this, you actually declare a Kotlin object that has those same properties in it. You've got some imports that you need to get to in order to get some stuff from the SDK. And then what's nice about this is that each of the Atlas Device Sync SDKs works to be idiomatic to whatever language it is that you're developing in, whatever target language you've got. So to the extent possible, we don't want you to have to learn about the Realm SDK. We want it to just work inside of your Kotlin app or your Swift app or your Flutter app or whatever it is that you're developing in. Okay, so let's walk through the code and see where those Kotlin item instances actually get created and used. Right, so here's the handler for the add item dialog. So when the create button gets clicked, the add task function and the add item view model gets called. Right, so there it is. And in the add item view model, we instantiate a repository using the sync repository interface. And then in the add task function down here, we dispatch the add task function in the repository and then handed the string that we entered from the task description. So task summary.value has the string that you type in, to actually name that particular task. Okay? And then finally, in the concrete function that implements the interface, we see the item get instantiated as a variable named task. So val task, right, all that. And then we set the owner ID to be the ID assigned to the user when we click the create account for that user. And then inside of that Realm write wrapper, we actually call the SDK method copy to Realm. And that persists the task object to that local Realm object there. And that's it, right? Look at all the code that isn't there. Your code just writes that item to Realm. If the edge device is online, then the task is synced to MongoDB Atlas. If it isn't online, no problem. The SDK takes care of syncing it whenever the network connection becomes available. So it's very easy to work with objects, right? There's no DAO class pattern, there's no ORM library, there's no conversion to JSON or back and forth like that. But moreover, there's no checking to see if the app is online or not. If it's online, there's no COM code there. There's no doing retries for COM code. There's no worry about data update race conditions. Your code doesn't worry about sync. You're not worried about setting up to receive push notifications from the back end. You're not worried about periodic pulls from the back end to get updates. You don't worry about conflict resolution at all, because the basic rules of conflict resolution are built into Atlas Device Sync. So in short, you just manage your objects locally on the mobile app and let the SDK just handle the rest. So, okay, fine, that's all fine for a sample application. But let's say you've already got a bunch of data on the back end in MongoDB Atlas. How do you do real world development on that for an existing data set that needs to have a mobile app created for it? So Atlas App Services lets you create a JSON schema and Kotlin code from an existing data set on your back end. So let's go try this out. So back in your Atlas project, go to the app service, click on the schema tab that's over on the left, and scroll through to find the database and the collection that you want to sync to your edge devices. Now in this case, we've already got one picked out. We're looking at the JSON schema that already exists for your item collection. And you can see, there's BSON definitions here, the binary JSON, that's BSON. So you've got types for the object ID and the Boolean and the couple of strings. Now this JSON schema here, it defines the shape of the data that you can actually sync between your mobile app and your MongoDB backend. So any object instantiated on the mobile app has to satisfy this schema in order to sync. And any document that you insert into your document collection in MongoDB on the back end also has to fit this schema. It has to satisfy this schema in order to be able to sync back down to your device, right? So this is the definition of the data that syncs back and forth. So the good news is you don't have to type that schema by hand. Just click the Generate Schema button that's actually on here on your JSON schema. You specify and you go pick out the database that you're actually syncing from. You specify the number of documents you want to sync and sample. There's some optional settings you can get to under here, but when you're ready, you hit the Generate Schema button to generate from your sampling, and you'll get this updated schema. It went and looked at all of the data that you had written in MongoDB and said, okay, I think it looks like this, it has this shape to it. You can go and modify this. You can hit checkboxes to say whether this is required in your schema or it's optional, but you can also get back to your JSON print view of the schema at any point. All right. After that JSON schema gets generated, then you go to the Sync Models tab, you select your target language of choice, and you copy code generated by Atlas App Services to paste into your app. So you can just hit the button, you copy this, you paste it directly into Kotlin for you. So you can think of this as the back to front development path. You go from your existing back-end data and to constructing your front-end code, right? So let's say you need to go in the other direction. Let's say you've got your existing mobile application and you need to make changes on the front end that will be reflected on the back end. So do you really have to make those changes on your front end and then recompile your front end app and then go to Atlas and update the JSON schema by itself? And the answer is no, you don't, if you've got development mode enabled. So with development mode on, any updates that you make to your mobile app class definitions get automatically handled by the back end. So in particular, the JSON schema gets automatically updated on the back end in order to accommodate whatever new object definition it is that now exists on the front-end mobile application. So let's walk through what that might look like in practice. So, okay, you've got an assignment now. You've got to add a priority field to your item object. So those values get defined in a property level enum. You say, okay, I got to go add this to my object. What does that look like? Okay, well, let's walk through the code. Let's go open up your item.kt. You're going to add a priority level enum and an int member variable down in your class to actually store that enum value. And then in the add item KT, we'll add some imports to enable a drop list on the add-on dialog. So this is a lot of UI stuff. But then at the bottom, we actually import the property level enum that you just defined. And then in the alert dialog, we'll add a priorities variable to hold the priority level values. And we'll add a drop-down with the expanded Boolean to indicate whether the drop-down is open or closed. And then we'll add that text field to actually hold the priority item label, right? So there you go. And then we'll populate that drop-down menu with the list of all available priorities values. So that little for each loop goes and populates the list. And then finally, we'll add this little click handler, the on-click, and that'll update the task priority in the view model whenever a selection gets made. We'll provide a string for the text label and add item, fine. And then in the add item view model, again, we'll import the priority level enum, and we'll add private variables for the task priority and the expanded state of the dropdown. So those get handled there. And then we'll add functions to update the task priority and open and close to open and close the little dropdown list. And then the actual add task function, there's a parameter for the task priority value. And then we'll also, dump that out to the log and as part of this log statement here. We'll reset the task priority value to low when we're exiting, so we do some nice cleanup on that dialog. And then finally, in the sync priority.kt, we'll again import priority level. We'll add the task priority as a parameter on the interface definition. And in the concrete implementation, there we set the value of that priority field when we're actually instantiating the actual item. And then that comes from that passed in priority level. Oh, and then for good measure, we'll update the mock. So that gets the new task priority parameter. Let's build and run. Okay, when we run, sure enough, the add-on dialog now has a priority dropdown. We add a task name prioritized item to that list with a priority set to high. And as soon as it gets saved to the list there in the middle, it immediately shows up in the back end. And sure enough, there's that newly created item. And you'll see it's got that priority field sitting down there, and the other two documents don't have it. So that's one of the ideas of a document database. You can just add fields to it. All right. Pop quiz. These guys definitely do not want to take the pop quiz. What code did not get generated to implement that priority field? All right, so what did we do? Well, we added the new priority member variable in item.kt. We added the UI elements and all those other things, and we didn't have to bother with, the database code, right? There's no database stuff happening here. They didn't write any SQL update scripts to insert a new priority column inside your SQL code. We didn't do any updates for your backend database. We didn't check to see if the update had already been applied or not applied in that upgrade script. You know, have you ever done like a SQL upgrade and got it working in your system and told your buddy, here, it'll run, it'll just fine, it works on my system, and it doesn't work on their system? Well, yeah, you don't have to do any of that, right? Oh, and here's that JSON schema update actually happening. So when you do that update, you add the priority level item field, it syncs to the back end, there's the log. And you see, there's it, adding in, there's the field being added, there's the log time, and there's your JSON schema automatically updated on the back end. Now think about this. You just updated the class definition of an object in Kotlin. You added some UI stuff and you hit go. And the front end database said, oh, okay. And the back end database said, oh yeah, no problem, here you go. And the sync stuff in the middle said, yeah, we can handle that, no problem at all, right? And that's just one more reason why we call this the easy way to sync your mobile data with Kotlin. So what else do you get out of the box with Atlas Device Sync? Okay, well, as a mobile developer, you're very likely going to have to handle updates on the back end and on the front end from clients that may be offline when updates are made. All right? How do you handle all of those updates from all of those sources and keep everything consistent? So with Atlas Device Sync, you get built-in conflict resolution. That lets you handle simultaneous updates and even offline updates whenever they eventually sync, right? So the built-in conflict resolution rules, those are straightforward. Deletes always win. Most recent update wins. Inserts in lists are ordered by time. And primary keys determine object identity. That's boring. I'm not going to demo that here. It is necessary, but boring. We use operational transform. That's the same underlying technology as in Google Docs. So when you get two users editing the same document, it keeps it straight and everybody's updates are, properly applied in order. So to show delete always wins, let's start with two devices. We're logged in as the same user over here. And we're going to add item 1, 2, and 3 while we're offline over here. No, while we're online. So here's item 1, item 2, item 3. So everything syncs. And then after these 3 items are added, we're going to take everything offline. We're going to delete everything on this. This is a Pixel 3a over here. So we're going to delete everything over here first. And then we're going to make updates on the middle one. He's still offline, but we're going to mark all those as complete. And then we're going to make some more updates on the back end. Okay, so there's some tasks being updated on the back end. We hit apply. And then as soon as we hit apply and bring these guys back online, why did I make 3 updates on these things? I've got 10 minutes left. I bring this back online, everything updates, but I bring this back online, and because delete always wins, everything just gets deleted. Now, if you don't like this behavior, right, don't delete objects. I mean, literally just put a Boolean inside your object that says is deleted and soft deleted, but leave it in the database. Okay. Most recent update wins, that's always easy to understand. The cool thing about this is, because we use operational transform, that employs Lamport timestamps. And that means you get an independent synced clock across every single one of your devices and distributed databases. So even if the times on your phones are off, or even if it's off on the back end, the Lamport timestamps stay consistent and everything is handled in proper order. So we're going to start with 2 empty devices again. And considering I have 10 minutes left, you may not get to see all of this, but basically you add stuff, you take devices offline. Oh, we might let it play. You mark everything as complete. In the back end, you also make updates, and then the back end updates actually win. So when the backend updates happen, those updates win faster than the updates on these things work. So basically you see last update wins. All right, take my word for it. Last update wins. The really cool conflict resolution feature here is that inserts and lists are ordered by time. So again, thanks to Lamport timestamps. And that means if you've got two offline clients doing inserts, updates, and deletes on array elements, all of those will get conflict resolved into the same order for those array elements. And what that means is, we can actually show this showing two empty inserts into devices here. And so what I'm going to do is take these offline and I'm going to add 5 elements. 1, 2, 3, 4, 5, but they get added on different devices. And then when we turn the sync back on, they get conflict resolved into the correct order in which they were actually added. I'm going to add one more. All right, and then when we bring these back online, you'll see it's 1, 2, 3, 4, 5 across the board. This is really cool. And then it comes back as the correct order here. So anytime you need a custom conflict resolution schema, you can rely on this because in fact, what we just built was an ordered history of all of your changes on any individual field. So you can use that history as part of a conflict resolution tool set. If you need to go back in time to any change that happened from any other user, you can build code to actually pick the right one out of that list because you can keep all of that history here. All right, and finally, because we're wrapping up, we're going to do quick hits on stuff we didn't get to. Authentication and authorization. You get all of that through Atlas App Services on the back end. Dynamic query subscriptions, that lets you in real time say, this is the set of records that I need to get off my back end. I'm going to write a subscription to these, make a query, and get just those records that I'm interested in. And anytime you get a change in any of those records in the back end, you let me know about it, and I'll have those updated. There are hierarchical rules on the back end where you can actually determine who gets to see what, who gets to read what, who gets to write what. It's all controlled in your Atlas App Service on the back end. So that security mechanism is in place for you. Everything that you see on the app services will also run through a CLI. So you can put everything that you're seeing here under CI/CD control and put it all under version control. Data ingest. Everything that you've been seeing here has been two-way bidirectional sync. You can also get a bidirectional data ingest method. So if you've got a million IoT devices and you need to slurp data off of those onto your back end, you can use data ingest for a quick one-way sync. Very nice. Edge server. Our standard sync architecture is your phone or your device connects directly to Atlas. If you need to put an on-prem device in your store or in your location, your devices will sync to that on-prem edge server. Edge server takes care of syncing to the backend on Atlas whenever there's a network connection available, right? And finally, there's a huge benefit of putting your data on Atlas, and that's the developer data platform. So the key feature of your MongoDB developer data platform is the document model. It lets you build a wide variety of databases on a wide variety of systems. Here's another view of the data developer platform. The only part that we've talked about is this set of boxes up here. There's many more things about application services, tools, integrations, and features on a very highly available platform that you can deploy across, as I said, Azure, AWS, GCP, any of those platforms. And I encourage you to try it yourself. The little demo that you saw here today can absolutely run on your back end. Stand it up, put it in Kotlin, put it in Swift, put it in whatever you like. I'm going to fly past this because this QR code's on the last slide as well. And if you want to learn more about MongoDB, we've got a developer day happening right here in London on December 7th. Grab that code. Again, I'm going to repeat that code on the last slide. Are we at time? We're at time. Thank you so much, everybody. I appreciate your time today.